Practice problem number 2, still associated with sample problem 3-5. How many atoms of sulfur, S, are in 4.00 grams of sulfur? Okay, so let's set up our initial information. So we have 4.00 grams of sulfur, and I am going to convert that into something. Well, without even thinking about it, even if I don't know what I'm supposed to end up with, I know that I need to cancel out of grams. So grams of sulfur is definitely going in this denominator of my first conversion factor. And I can only convert into moles from grams. I don't have anything else in my toolkit at this point that allows me to convert from grams directly into number of atoms. But I can convert from grams into moles. Okay, now once I'm there, I'll be able to convert out of moles and into atoms of sulfur. And you can see, once I do my calculations, grams will cancel with grams and moles will cancel with moles, leaving only atoms as my unit. But the question is, what numbers do I put in these conversion factors? Well, I need 2 statements of equality if I have 2 conversion factors. So what is a statement of equality that relates moles of sulfur and grams of sulfur? Well, I know that if I have 1 mole of sulfur, I have 32.07 grams of sulfur. Okay, so that's going to give me the information I need to fill out this conversion factor. What about this one? I'm going to use Avogadro's number. 1 mole is equal to 6.022 times 10 to the 23rd atoms. So let's fill them out. What do I put in front of this mole? Whatever I have in front of this mole. What do I put in front of this gram? Whatever I have in front of this gram. What do I put in front of this atom? Whatever I have in front of this atom. What do I put in front of this mole? Whatever I have in front of that mole. And now we're ready to calculate. Now, I'm not going to do anything with that power of 10 right there in the calculator. I'm going to do that at the end. I'm just going to use my own brain skull to think that through. So into the calculator, I am going to type 4.00 times 1 times 6.022 and then divide by 32.07 divided by 1. All right. Now, the problem had me start with 3 significant figures. So my answer needs to have 3 significant figures. So I'm going to take what my calculator has given me, which is way more than 3 significant figures, and round it to 3 significant figures. So this looks like it would end up being, 0.751. Okay, so correct number of significant figures, but what about that power of 10? Well, it's the only term, right? Avogadro's number right here is the only term in this entire conversion that has a power of 10. So there's nothing to multiply it against and there's nothing to divide it by. And so it really doesn't change. It just stays exactly the same. So keep it the same. Here's my only issue. That's not in proper scientific notation. To get it in proper scientific notation, I need to move the decimal 1 place. So I'll have 7.51 times 10 to the something power atoms of sulfur. But the question is, I've moved the decimal 1 place. Does that mean that my exponent needs to get 1 larger or 1 smaller? Well, in order to make this go into proper scientific notation, I took this number that was less than 1 and I made it more than 1, right? Now it's 7.5. And so this part of the number, the way I'm representing the value, has gotten larger. So in order to balance that getting larger, I need something to get smaller. So this is actually going to get smaller by 1. So my final complete answer with the appropriate number of significant figures is 7.51 times 10 to the 22nd atoms of sulfur.